Hello everyone. In the previous class, we already discussed about the Venturi meter. In today's class, we calculated some problem regarding the Venturi meter. Myself, Samresh Pratap Mahanti, Assistant Professor, Department of Mechanical Engineering, Vedang Institute of Technology. So let's start and solve. We will solve some problem. First, this is the first question. A horizontal Venturi meter with inlet diameter 20 cm and throat 10 cm. That means inlet diameter means your D1. Solution. Your D1 is equals to your D1 solution. Your D1 is equals to 20 cm. I converted it into meter, 0.2 meter. And inlet diameter 20 cm and throat 10 cm. That means your D2. D2 is equals to 10 cm. That means 0.1 meter. Now A1 square is equals to, now your value of we have to find the first the value of A1. A1 is equals to pi by 4 D1 square. That means pi by 4 into your D1 value 0.2 is equals to 0.031 whenever we calculated it in a scientific calculator. Your A2 value is equals to pi by 4 your of D2 square. That means 0.1 square is equals to pi by 4 into 0.1 square is equals to 0.007. Now then comes to the question, the flow of oil of specific gravity. Data given the specific gravity of oil is equals to your 0.8 and your CD value, that means the coefficient of discharge is equals to CD is equals to 0.98. Generally for mercury, one point to be calculated. Generally for mercury, your SS value is equals to 13.6. As we know that specific gravity is unitless. Now comes to the problem, and your data also given Q is equals to 60 liter per second. That means 60 divided by 1000. 0.006 your discharge. Now we know that Q equals to PD A1 A2 root over of 2GH divided by A1 square minus A2 square root over. Now putting the values, your CD is equals to 0.98, your A1 is equals to 0.031, your A2 value is equals to 0.007, and we know that G value is equals to 9.81 and your H is not given. That implies that Q is given. That means 0.06 is equals to 0.98 into 0.031 into 0.007 into your root over of 2 into 9.81 into h. By calculating it in a scientific calculator, we find the value of h is equals to 2.89 meter. We find h. Now we calculated that your h is equals to x whole into sh minus so minus 1. Now sh value is equals to, for mercury 13.6, so given 0.1. Now h is equals to x your 13.6 divided by 0.8 minus 1. By calculating this h value given, we calculated the h value 2.89 is equals to x 13.6 minus 0.8 divided by 0.8. By calculating in a scientific calculator, the value of x is equals to 0.180 meter. This is the required value for x. I think everyone should be understand properly, but we have to calculate it in a scientific calculator. Okay, then comes to next problem. I think everyone is clear. The question given, a horizontal venturimeter inlet and throat diameter 30 cm and 15 cm. That means D1 is equals to 30 cm and your D2 equal to 15 cm. Solution. Your D1 is equals to 30 cm is equals to 30 cm. D2 is equals to 15 cm. Question given is connected to the reading of a manometer in the inlet and throat is 20 cm of mercury. That means x is equals to your 20. Then coefficient of discharge is equals to 0.98. Now D1 is, that implies that A1 is equals to pi by 4 into your D1 square is equals to pi by 4 into 30 whole square is equals to 0.07 meter. A2 is equals to pi by 4 into your D2 value 15 square. By calculating it in a scientific calculator, its value equal to 0.176 meter square. Every calculation should be done in a scientific calculator so that actual value we will be find. Now we know that your discharge Q is equals to CD A1 A2 root over of 2GH divided by A1 square minus A2 square root over. Now putting this value. H, we do not find H, so your H is equals to x of SH divided by SO minus 1. Now H is equals to X, data given X is equals to 20. For mercury we consider 13.6. For oil it's normally 1 minus 1. By calculating this in a scientific calculator, the H value is equals to 2.52 meter. Now your Q is equals to CD A1 A2 root over of 2GS divided by A1 square minus A2 square. Now Q is equals to, putting the value, CD 0.98, your A1 is equals to, your A1 value is equals to 0.07, your A2 value is equals to 0.176 into root over of 2 G value is equals to 9.81 into your H value is equals to 2.52 meter divided by A1 square minus A2 square. 0.07 square minus 0.176 square. Your Q value is equals to 0.012. By calculating it in a scientific calculator, the value is equals to, your Q is equals to 0.12. 0.012. I think everyone should be clear in this problem, no doubt. Then comes to the next problem. Water is flowing through a tapering pipe having diameter 300 mm and 150 mm. The discharge through the pipe is 40 liter per second. The data given, so D1 is equals to, D1 is equals to 300 mm is equals to 0.3 meter, converting it into meter. So D2 is equals to your 150 mm. 150 mm is equals to 0.015 meter. Then discharge is equals to, Q is equals to 30 liter per second. That means 40 into 10 to the power minus 3. Now given that the datum head, your Z1 is equals to 10 meter and your Z2 is equals to 6 meter. First we have to find the area. A1 is equals to pi by 4 D1 square is equals to pi by 4. So D1 value is equals to 0.3 square. By calculating this, then A2 value is equals to pi by 4. Your D2 square is equals to pi by 4, your 0.15 square. Then A1, A2, for simple process we should not calculate the value of this. Okay, then we know that your Q1 divided by rho g plus V1 square divided by 2g plus z1 is equals to p2 divided by rho g plus v2 square divided by 2g plus z2. But data given here, the pressure at one section is 400 kilo Newton per meter square. That means your P1 is equals to 400 10 to the power 3 Newton to the power 3 kilonewton meter square. Now V1 and V2 value we do not know. Then we know that Q is equals to your A1 V1. Now V1 is equals to Q by Q divided by A1. Putting this value, Q value is equals to 40 into 10 to the power minus 3. Then A1 values pi by 4 into, solving this, we find the value of V1 is equals to 0.5659 meter per second. Then Q is equals to A2 V2. Similarly, V2 value is equals to Q divided by A2. That means 40 into 10 to the power minus 3 divided by pi by 4 into 0.15 square. Simplifying this, the value is equals to 2.264 meter per second. Everyone should be calculated this problem in a scientific calculator so that the actual value will find. Then putting the values of every P1 is equals to your 400 10 to the power 3 divided by rho is equals to your 1000, G is equals to 9.81 plus V1 square, V1 value is equals to 0.5659 divided by 2 into 9.81 plus Z1 value is equals to 10 plus 10 is equals to P2. We have to calculate the value of P2 divided by 1000 into 9.81 plus V2 value. Your V2 value is equals to 2.264 divided by 2 into 1000 plus 6. Simplifying the above equation, we find the value of P2. That implies that P2 value is equals to 37.24 kilonewton per meter square. This is the value of P2. We should simplify it in a scientific calculator so that the accurate value will conclude. Okay, I think everyone should be clear regarding the three problems. In the next class, we'll discuss about another chapter. Okay, thank you.